If you've seen our other videos, you've seen why you might want to use clickers and how to do it effectively. Here, we'll show you some of the research related to how clickers are used in the classroom.
Here at CU, we've been trying to study how clickers are actually being used.
Chandra Turpen has been involved in research on clickers for many years.
And we found there are a variety of ways in which faculty members use clickers. And some faculty's classroom practices surrounding clickers are more or less effective than others at promoting student discussion and promoting interesting student questions. For example, one simple thing is that when faculty tend to walk around the classroom and leave the stage, it's more likely that those faculty are asked questions or are engaged in discussing with the students. From our classroom observations, we've noticed that faculty often tend to quickly jump to the correct answer. In the few courses that we have as examples where faculty are discussing the incorrect answers, we've noticed that there is a much more complex and more lengthy discussion of the solution that is usually productive with students bringing up interesting and complex questions.
I would say one of the things I dislike the most is when professors don't talk about the answer.
There's a tendency when faculty asks really simple recall questions or definition questions for students to think that that's the primary purpose of the course, is for them to learn those definitions and be able to recall those facts. But in classes where more challenging and conceptual questions are asked, students tend to realize that the emphasis of the course is about reasoning and arguing and coming up with the correct answer amongst themselves.
Clicker questions aren't helpful when I'm just repeating what the teacher has just given me. I like to have the questions progress the class rather than just a regurgitation of what I've been told.
Students tend to really like clickers, so here at a survey that we ran at the University of Colorado showed that about 72% of students either strongly recommended or recommended that clickers be used in their courses. So in courses where student discussion was encouraged during the use of clickers, these students reported that they would encourage the use of clickers in other courses. I would say one of the intuitions that faculty members start with clickers is that it's a quick and easy way to check in with their students, but they tend to ask quite simple questions when they start out. And we've found through surveying of students that students don't prefer clickers to be used in a manner where they're just being kind of checked in with or quizzed on whether they know a certain vocabulary or they're able to do a certain type of calculation. Students report that challenging conceptual questions are much more useful for their learning, at least from their perception. There have been a significant number of research studies done to document the effects of interactive engagement techniques. One of the landmark studies that I wanted to share with you is Richard Hake's 1998 study of 6,000 students. In Richard Hake's data, he's looking at force concept inventory results of 6,000 students over an assortment of courses. And he represented this data in a plot where the fraction of courses was plotted on the y-axis, and on the x-axis was the fraction of what students learned out of what they could have learned. This test primarily measures students' conceptual knowledge about Newton's laws. Richard Hake's results showed that in traditional lecture courses, students only learn approximately a quarter of what they could be learning out of the course. In interactive engagement courses, he found that learning gains ranged from 25% to 70%. So in this way, the lowest achieving interactive engagement courses performed as well as the highest achieving traditional courses. This research was followed up here at CU to examine how our courses performed using peer instruction, which is a form of using clickers with peer discussion. We find that with the use of peer instruction here at CU, that we achieve student learning gains ranging from 25% to 45%. When we augment the use of peer instruction with additional interactive engagement techniques, such as the use of small group discussions and recitations and the use of the tutorials curriculum, we see learning gains that range from 35% to 70%.
Eric Mazur wrote the book Peer Instruction, which first popularized this pedagogical approach, where faculty members would pause intermittently throughout their lectures and ask their students questions. Students would then answer these questions using peer discussion.
In Eric's approach to asking questions, he would first ask the question individually and have the students vote on their answer to the question. He would then follow up this individual answer time with a peer discussion time and have the students vote again after discussion. And what he found is when students were answering the question individually, they were choosing many different answer choices. And then after peer discussion, they were gravitating towards a single answer option that was usually the correct answer. So as a follow-up study to Eric Mazur's work, Michelle Smith and colleagues at the University of Colorado did a study where they added on to Mazur's study. This study was motivated by a concern of many faculty, which is that the increase in correct responses after peer discussion is merely the result of students getting the correct answer from their peers, but not learning anything from these discussions. So Michelle Smith and her colleagues at the University of Colorado did a follow-up study on Mazur's work.
Students were asked 2 questions. The first time they answered question 1 individually. They then responded to question 1 again following peer discussion. Students were more likely to get the first question correct following peer discussion. Students were then asked a second question on a similar topic and were asked to respond without talking to each other. In this case, the researchers found that about 75% of students could solve it correctly, indicating that students had learned something from the first question that they could then apply independently.
We find this to be quite compelling proof that students aren't just getting the correct answer from their peers, but are actually learning something that they can then use in the future. Many faculty were concerned that the student groups required a student that knew the correct answer, so they believed that there was probably one knowledgeable student in the group that was then telling the other students the correct procedure and that students were then able to reproduce it.
So Smith et al. Wanted to see if it was necessary to have one knowledgeable student in a group in order for students to get the right answer in a clicker question.
And when they looked at the difficult questions, they realized that there was less than 20% of the class getting the correct answer at the beginning. This meant that the majority of groups in the class didn't have someone in their group that knew the right answer. This meant that for a subset of these questions, there were student groups in which no one in those groups knew the correct answer, however were able to come to the correct answer through peer discussion.
These are just some of the research results showing that overall, interactive engagement helps students learn. Clickers are only one of the many types of interactive teaching. Studies show that students like clickers, especially when used with peer discussion, and that talking to their peers helps them understand the material. For more on our group's research, go to per.colorado.edu. And for more resources and videos on clickers, go to stemclickers.colorado.edu.